Okay, so section 8.3, day 2 notes, essential question, how do you graph a rational function by hand? So at any time, if you need to pause throughout because I want you to work out a problem, or you are still copying things off of the board here, then just pause and you can restart it when you're ready. So today we're going to graph 4 functions, and you have them on your paper. Right now I'm going to do example 1, just doing what we did last night, finding all of the asymptotes, the holes, and the intercepts. We'll walk through this one together, number 1, and then you'll pause, and I want you to work with your table partner to see if you can find the rest of these, the asymptotes, the holes, and the intercepts for the rest of them. But I do want to work out number 1 with you to remind you how to do that. And then you're going to work together to try and do numbers 2, 3, and 4 before we come back and try and graph them all together. Okay, so first, number 1. So first thing, what are we supposed to do? Hopefully you are saying factor. So we are going to have, this is going to become y equals x plus 1 we can't do anything with. What would the bottom be if you factored that one? X plus 4 and x minus 2, because that would multiply to give you -8 and add to give you positive 2 in the middle. Okay, so factor is the first one. Can we cancel anything? No. So in this case we can't cancel anything, so that tells us if there are holes or not, and since we cannot cancel anything, then we have no holes in our graph. Okay? Now I'm going to do my asymptotes next. So to get vertical asymptotes, remember you look at the denominators. So my first one, my first vertical asymptote is going to be at x equals -4. My second one will be at x equals 2. So it's possible to have more than one vertical asymptote. Okay, so now looking at this, since we didn't cancel anything, to get my horizontal asymptote, I'm just going to come back and look at this one, look at the original. And so horizontal asymptotes, you compare the degree on top and bottom. So the degree on bottom is bigger, so then what is my horizontal asymptote going to be? Y equals 0 will be it. Sorry about that. I'm recording it after school and there's been some announcements here and there. So since the degree on the bottom is bigger, that means that your horizontal asymptote is going to be at y equals 0. Slant asymptote. To decide if there is a slant asymptote, then you look and see the top degree has to be bigger by 1. Well, in this case, the top degree was smaller, so this has no slant asymptotes. Okay? Then to find the x-intercept, so remember to find the x-intercept, you go back and plug in 0 for y. So then I have this situation. Okay, so to solve, we need to get rid of that denominator. So what do I do to get rid of that denominator? Right, you multiply by the denominator. Now, when you multiply anything by 0, you get 0, and then over here, this cancels, so you're left with 0 equals x plus 1. So now solve for x. So x equals -1. So then my x-intercept is the ordered pair -1, 0. Okay? Now, to get your y-intercept, that is when you plug in 0 for x. So I go back up here. So y equals 0 plus 1 over 0 plus 4, 0 minus 2, That's going to be 4 and negative 2, so that's going to be 1 over 4 times negative 2, which is negative 8. So then my y-intercept is going to be at the ordered pair 0, negative 1/8. Okay? So that is a review over what you had to do on your homework last night to find all the asymptotes, the holes, and the x-intercept, y-intercept when the directions asked you to find all of those items. So then I want you to pause now, and I want you to go through and find the rest of these items for example 2, example 3, and example 4. So go ahead and pause and take about 20 minutes to do that, because it'll take you a little bit of time to remember how to do all that and double check with your table partner and work together. Okay? Okay, so you've had some time to work, so let's go over finding all of these missing pieces together. So first we factor, so this is now going to become y equals x plus 1, x minus 1, and then this bottom is not going to factor any further. Okay? Now, nothing canceled, so that should tell you that there are no holes in this graph. Okay, so next thing I'm going to look at is vertical asymptote. So vertical asymptote is when you look at the denominator. So that one's not factorable, so I'm going to set it equal to 0 and solve. So if I minus 3, I get x squared equals negative 3, but when you square root, that's an imaginary number. So imaginary numbers we don't do, so that means that there is no vertical asymptote, because it came out to be imaginary when you set the denominator equal to 0. Now, horizontal asymptote, since nothing canceled, you can go back to the original problem and compare the degrees. The degrees are the same, so what are we supposed to do when the degrees are the same? Well, you take the top coefficient divided by the bottom coefficient, so 1 divided by 1 is 1. So y equals 1. Okay, so that's your horizontal asymptote. Now, slant asymptote is when the top degree is bigger by 1. Well, we don't have that situation here because they were the same, so there's no slant asymptote. Okay, now let's do x-intercept. So x-intercept was when you plugged in 0 for y. So then we multiply both sides by the x squared plus 3 to get rid of it. So that'll be 0, that cancels, equals x plus 1, x minus 1. So this has two x-intercepts at negative 1 and positive 1. So then I have negative 1, 0, and 1, 0 is where it touches the x-axis. Now let's do the y-intercept. So that's when you plug in 0 for x. So then that'll be y equals 0 plus 1 times 0 minus 1 all over 0 squared plus 3. So that's 1 times negative 1 all over 3. So that's negative 1/3. So that'd be 0, negative 1/3. Okay. So that's your y-intercept. So that was what you should have gotten for number 2. Number 3. So we're going to factor. And you can replace f of x with the variable y. That just makes things easier. So then the bottom, you should have gotten x minus 3x plus 3. So this time something does cancel. So what cancels is the x minus 3's. So then what's left over is y equals 1 all over x plus 3. So we are now going to look at this from now on when we finish the rest of these. But this tells you, since we canceled, that x equals 3. Oops. So we've got to come up with the ordered pair where the whole occurs. And so since we crossed out x minus 3, that means x equals 3. So to find out the y value that goes with this, you plug that 3 in here into what was left over, because we're no longer going to look at this other stuff because we're only looking at what was left over. So then that's y equals 1 over 3 plus 3. So that'll be 1/6. So that is where the hole is going to occur in our graph. Okay, so the 3 came from what we canceled out, and then I got the 1/6 by plugging it into what was left over, because this is now what we're going to use to find everything else. So vertical asymptote, look in the denominator. So x plus 3 is in the denominator. Your horizontal asymptote, it should be x equals -3. Oh, sorry, I wrote that in the wrong spot, didn't I? Okay, so then next, we want to find the horizontal asymptote. Well, if there's just a 1 up here, this is technically x to the 0 power. So the bottom degree is bigger than the top degree. So that tells you that your horizontal asymptote should be at y equals 0. Okay. Slant asymptote, since the top degree is not bigger by 1, then there is no slant asymptote, so you should have put none there. X-intercept, so again we plug in 0 for y, so that'll be 1 over 0, x plus 3, so then we multiply by x plus 3 to get rid of the denominator. 0 times anything is 0, and so now 0 equals 1. That's a no solution because that's a false statement and there's no more variables. So then that means that there is none. There is not an x-intercept. Then to get your y-intercept, you should have plugged in 0 for x, so that's 1 over 0 plus 3, so then that equals 1/3. So then that is your y-intercept. So those are the answers you should have gotten for that problem. Okay, the last one. This one we can't factor anything, so I'm left with this. And we can't cancel anything, so then that tells you that there are no holes. Vertical asymptote, look at the denominator, so vertical asymptote is x equals -1. Horizontal asymptote, the top is bigger than the bottom degree, so then there is no horizontal asymptote, but this is one where we do have a slant asymptote, because the top degree is bigger than the bottom degree by 1 unit. So then we are going to have to divide, and I can do synthetic division for this one because this is x plus 1, so it's a 1 in front of the x. So then I put my box. I put -1 outside because you put the opposite. Inside, this is 1x squared, then I need plus 0x plus 0, so you can't have any gaps. You bring down the 1, multiply, -1, you add these, -1, multiply, you get +1, add them, and you get 1. Remember, this last one is the remainder, so we ignore that. So then you get x minus 1, so 1x minus 1. So y equals x minus 1 is your slant asymptote. So again, for the slant asymptote, if the top degree is bigger by 1 unit, which it is, then you can divide this into this so that you get the equation in the y equals mx plus b form, because it is a slanted line. Okay? And the remainder we always get rid of, and then these two, this first one's x, and then this is your y-intercept. So you will have to start the next video to see the rest of this problem worked out in the graphing.